Algebra 2. This is Unit 1, Quiz 2. We are here to discuss how to identify the equation. It says find the equation of this function. So first we need to recognize that it is a child of the parent function 1 over x, but then that there might be a horizontal transformation that would happen here, or there might be a reflection or a stretch that would happen out here, or there might be a vertical shift that might happen out here. So to identify those, the best thing for the reciprocal function to do is to draw in your asymptotes, because the asymptotes usually meet at 0, 0 for the parent function. So wherever those asymptotes actually do meet is your new h and k. So we have the point right here that is 2, 1. That is our new h and k. We have shifted to the right by 2 and up by 1. So we throw that into our function down here. To the right by 2 is actually x minus 2, because it's always x minus h, and h is a positive 2. So we see x minus 2 when the function is moved to the right. 1 is up. We actually see plus 1 outside of the grouping symbol that is your fraction bar. Outside of that is over here, and that's where we see the k. So now the question is it reflected? Well, this would be quadrant 1. And our function usually exists with positive x's and positive y's. Our reciprocal function, if we choose a positive x, we also have a positive 1 over x. So this has not been reflected. We expected to see the function in Q1 and Q3, quadrant 1 and quadrant 3. So no reflection. This will be a positive. The other thing that we're looking for is the whether there's a stretch. Now, if you were able to identify this much of the transformation, I give you credit on the quiz. But on the test, I'm looking to see that you also can say, well, one of our key points is usually here at 1, 1. So I have a point that's usually right here at 1, 1, but it's been pushed up, multiplied up there to the equivalent of 1, 3. So it turns out that this isn't 1 over, this is 3 over x minus 2 plus 1, because of that stretch that brought the point that usually is from the origin or from our intersection of our asymptotes over 1 and up 1. It actually is over 1 and up 3. So that relative position between the axis intersection and where we usually have our key point 1, 1, that's what tells us there's a vertical stretch by 3. But again, on the quiz, I would have given you credit for just the shifts. So let's take a look at what we can do with this function here. Again, another opportunity to identify an asymptote. When we sketch these functions, I want you to write the equation of the asymptote. This is y equals negative 1. Running off the edge of the screen now. But in our parent function, that's y equals 0. So we must have a minus 1 going on outside of the actual parent function. Now, identifying what the parent function is, hopefully we recognize this asymmetrical end behavior as one of our b to the x functions. Now, there's a couple of things going on here. There might be an a happening out here that's multiplied by b, or there might be a minus h happening here inside of our grouping symbol. I can't get it to draw the minus. Okay, x minus h. The grouping symbol here is not really a truly symbol, but the fact that you write it small and up high. That is the indicator that x minus h is all part of the exponent in this exponential function. So another way to do a grouping symbol without a parentheses is to write it small and up high to be part of the exponent. But we have to identify what the b is. Now, normally in our parent function, the point that is 1 above our asymptote is our y-intercept, 0, 1. But in this case, it's not 0, 1. The actual point ends up being 1, 0, which is weird. But it's 1 above the asymptote. And so this height here, this movement, that's telling me that's my new key y-intercept point, which means not only did I move down by 1, I also moved to the right by 1. So this will read, my exponent will read x minus 1 in the exponent. Now, I need to know what my base is. I assured you during class that there was no a here. There was no stretch. And we can see that there is no reflection because it is growing exponentially in an increasing manner. So that it's not been reflected either. So our a is 1. We just need to figure out what the actual change is as we move to the right by 1. So when we go from this base blue point, I'm going to make it pink here, I go over 1 and up 1. Interesting, which means off of the asymptote, this would normally be the point 1, 2. And the point directly to the right of what used to be, right, our parent function used to be right here. That was the y-intercept was here, and our x-axis was here. So this used to be the point 1, 2 in the parent. In our, what that means is that every time we step over by 1, we double. So over by 2 goes up by 4. Over by 3 would go up by 8, which we can't see on this graph. So we can see that this is a doubling function, so the base is 2. I'm going to come out and throw in a 2 into my function. The base is 2. So this is actually our function. It is the exponential function shifted, that is base 2, 2 to the x minus 1, shifting it to the right by 1 and down by 1. K is negative 2. Okay, so all about relative positions versus the parent. Now at the bottom here it says use function notation to describe transforming the function h of x by shifting it to the right by 2 units. So now I'm going to say my h is 2. Going to the right is a positive 2, meaning I'm going to be seeing an x minus 2 somewhere in my function. And reflecting it across the x-axis. Okay, a reflection means a negative across the x-axis. That is our vertical reflection that takes our y's from positive down to the other side of 0 to negative. So what we're going to see is if we're modifying this function in function notation, that is minus or negative h of x minus 2. Sorry. Apologize for the handwriting. And there is no shift up or down, so our k is 0. So that is actually the answer to this question. Now it also says to sketch the resulting function if h of x is the absolute value of x. So I can go back to the verbal description and say, okay, I'm going to take my parent that looks like this, and I'll change colors. Let's go with pink again. If my parent looks like that, I shift it to the right by 2. So there's a point now over here, and reflected across the axis. So it's going to go like this. Now it's important that I label this point as 2. I've told you before that hash marks are kind of the old counting on your fingers thing, right? What if I had said go to the right by 87? Hash marks would not have been appropriate in that context. So we're going to not usually draw hash marks. We're going to label our x-axis. In fact, we could just label the point 2, 0 even better. Labeling our key points is very important to sketches. So that was that quiz. In this last question on the quiz, it says, what family of function best fits the data? So I'm asking what family? That's the name of the family. So I plotted these points in roughly relative terms, right? So these 3 points all went over 1, up 1, over 1, up 1 here in the middle, right? So I went over 1, up 1, over 1, up 1, which was interesting. But all the other 2 points definitely did not. There we go. But the others did not follow that linear pattern. So hopefully I can sort of see that if I connect these dots, I'm going to end up with a cubic looking function. So what I'm looking here for is cubic, the cubic family. Quiz B, notice that the parabola is not stretched in any way or reflected because all 3 key points are where they belong. But they have been shifted. That vertex is at -1, -4, so it's x plus 1 because minus a -1 looks like x plus 1 squared, and then -4 outside that operation. Similarly, our exponential function has been reflected vertically down. That's what the negative does here. This minus sign says, take all my y values and make them negative. And that is happening outside of the base function 2 to the x. There is no shift, so the h was 0. This would have been x minus h, except for it was x minus 0, so that goes invisible. Now when we use function notation for a shift down by 3 and a stretch vertically by 3, we end up with 3 times g of x minus 3. Everything that happened was vertical, so nothing changed about x inside the parentheses. We just took the outputs g of x and multiplied them by 3 and shifted them down by 3. Data here similarly had an over 1, up 1, over 1, up 1 amidst these first 3 points situation, but then we kind of jumped by 2 and jumped by 2, so that's over 2, up 2. And we maintained that linear relationship, but then we started going down. So if we fill in the gaps here with some points that would be along the same slopes, it looks like this is linear in this direction and then starts going linearly down. That is an absolute value. So the word absolute value would be what I'm looking for here. That is the family of functions that this is. It's reflected to flip downward and it's shifted up by 3, but it is absolute value. Now looking down at this function, it is recognizable as one of the step functions. The only one we've learned so far is the greatest integer function. Now, what's happening with this greatest integer function? Well, we need to remember what the parent looks like. Usually the parent comes across here and has a circle there, comes across here and has a circle there, comes across here and has a circle there. So it usually is sort of home-based at 0. I'm going to choose to shift this one down by 1, so I'm going to take a -1 approach to get this piece from the parent to fit into this new spot. But the problem is my normal step is up by 1. This one clearly has a step that is larger than that. To go from one to the next, I actually have to step up vertically by 3. That is a vertical stretch. So there is a 3 right here, and there's no horizontal shift, so this is the greatest integer function that they're talking about. And this is a cube root shifted by up by 5 and reflected. So there's a minus. cube root of x shifted up by